Hello, Tom from everystepcalculus.com, everystepphysics.com. A problem regarding the Simpsons rule with the n equals 10, n equals intervals. Let's do it. Index 8 to get to my menu. I'm already scrolled to Simpsons rule. I show you the formula, or certainly for the integral. And you have to press alpha before you enter anything in here. We're going to add the integral now that's given. Student gave this to a number of us to answer on Yahoo, and so I'm going to answer it for him or her. Alpha 1 divided by 5 times x to the 5th power. I always show you what you've entered. Change it if you want. I say it's okay. We're going to add the limits. The limits are given as alpha 0, or the range, and alpha 5. So that looks pretty good. And they want the number of intervals to be 10, alpha 10. And here's the Simpson rule formula. Delta x divided by 3 times f, the function of xo, 4 times the function of x1, 2 times the function of x2, etc., etc. You can do as many as you want, but then it ends up to be xn minus 1 right before the last term you want to enter, and then the function is x times n, which I do in my programs here. First we find delta x, which is b minus 1 divided by n equals 1/2. And then we compute the intervals. At n equals 10, xo at 1/2 times 0 is equal to 0. x1 is equal to 1/2 times 1 equals 1/2. x2 is equal to 1/2 times 2 equals 1, etc. for 10 times, all the way up to 10 intervals, which I do. Then delta x divided by 3, we're adding this into the formula now, is 1/6 times all this quantity here. And the intervals are 0. We're entering these back into the function, and the quotations are means that I've replaced the x for the amount of 0 here. And x is replaced by 1/2 x, just like our intervals did before. You mark this all in your papers. Make sure you don't forget anything. So then the decimal system, all these are computed. Each substitution is computed here. And of course we add those, becomes 3.13 e to the 3 times 0.167 equals 520.938. Pretty neat, huh? everystepcalculus.com. Have a good one.